Hello, welcome again to this YouTube channel. So basically today we're going to look at how can we solve this particular problem. For example, I show you one simple function, okay, but not that simple because we are dealing with a quadratic function, okay. So if you look at this particular question, okay, you can see I'm going to show you how can we best use table form or a graph form or also a simple algebraic form to solve this particular problem. Okay, but first things first, based from our previous discussion, okay, we know that when we want to find these particular values, okay, we need to make sure that we have both the function, okay, I just put fx right now, okay, where your x goes to 4 from my right hand side must be the same with my limit for x goes to 4 less than coming from the left hand side. Okay, so if this is the same, then we can safely say that our limit exists over here. Okay, so how to check this particular equation whether it's similar. Okay, now I construct two different table altogether. The first table, you see my x goes to 4 from my right hand side, and the second one, my table when x goes to 4 from my left hand side. Okay, so how to select points where my x goes to 4 from my right hand side. Okay, so let's start first. Okay, when you go to the right, meaning that I need to make sure I choose or select one number that is from my left, right? Because left goes to right. Okay, so we start with 3.9. Okay, you need to find number that is closer to this value because you don't know what type of function that you have. All right, so it's maybe you have lots of different local minimum or local maximum. Okay, so to make sure that you didn't get confused with the value that you have, so that's why you need to find a very close numbers near to your fall. Okay, so how to make it even more closer, the next table you need to find number that is much closer to 4 compared to your first column, and then next, of course, you get the idea. You find the second or the third next close. And then finally, the most the closest value. Okay, so in this case, I just play around with my decimal points there. All right. So once you already dedicate your four or at least four different values altogether, now you can put into your function over here. Okay, so my first value, you just plug in your values inside your number there, and then I do the same for my second column, 7603, and then for the third column. Okay, when I write this, okay, you can see that the number increases, right? But it does not increase that much. It increases, and you can see as I play along and try to move it a little bit closer and closer and closer, you can see the pattern there. It will go to certain numbers, okay, just one particular number there. Okay, so what is the number? Okay, we will look at it later. And then the same thing happens when you make your x go to 4 from your left hand side. So the same thing happen, but in this case, you do the alternate direction. Okay, the first one, 4.1, and then this one is 0, and then we have 4.001, and similarly you do the final values there. Okay, and as the same thing you do earlier. Okay, so this is my values when I put my number inside the function. Okay, and you can see over here the same thing happen. Okay, it's just that the number is a little bit different, but as you look more carefully, you can see from my upper table, okay, my 46.9976, I think it will converge to 47, right? Okay, And as you can see over here, 47.0024, I think it will also move forward and converge to 47 also, correct? So this is what it means by that. When you put that into equation, okay, you can just say that this one, you have the value 47 over here. And the second one, you also have the value 47 over here. If this particular value has the same number, now you can say this is my solution for this particular limit for my function when my x goes to 4. Okay, that one settle for the table form. All right. Now we proceed to the second ways to solve this. Okay, whatever happen if I have the graph? Okay, so this is my graph. All right, the red in color is the function for my 3x square minus 4, and then I need to find my x when x goes to 4. Okay, so actually this is the value. Okay, imagine that there's no need over here. It's just that I'm afraid you didn't see the solution there. Okay, so this is my 4 actually. So what I want to know is I need to find my value when x goes to 4 from my left hand side, and my right move to 4 from my right hand side. Okay, so this is whatever happened. So meaning that if let's say this is number 47, okay, just imagine this is 47. So what I need to find is, okay, what is the limit when my x goes to 4 from my right hand side. Okay, and you can see meaning that this is your x. It when x goes to 4, okay, meaning that it goes like this. So you imagine we are dealing with our fx. Okay, so you can imagine our x as fx must move forward to this particular direction. Okay, so you imagine by the end of the day it will reach to 47. Okay, similarly, you have when your limit x goes to 4 from your left hand side. Okay, the same thing happen. You move your cursor. Okay, this is your, imagine this is your fx value, also goes to 47. So see, the same thing happen. You have your left hand side 47 and your right hand side 47, meaning that you can conclude that your limit over here is also equal to 47. Okay, so this is the example of what is the how you're going to solve this particular function when you have the limit, and you know that your s goes to 4, and this is the kind of the solution for your graph form. All right, last but not least, okay, the algebraic formulation. Okay, algebraic formulation is the most significant ways on solving this, as simple as it is. Okay, why I said it's simple? Because once you have a function that is straightforward like our function right now, you can just simply put the value 4 inside your quadratic function. Okay, just as similar as how you solve your point in a function form. Okay, so basically this one you just use your calculator, you get this. All right, so I hope you understand the lesson for today. All right, so I'll see you guys in the next lesson.